things, and then individual modules. Then we can uh, decompose those things. And okay, so we were discussing about the computational thinking. So normally, while solving the problem, that is different. Solving the problem is different. Normal way. In a computational manner, if you're solving, what we are doing, we're decomposing the problem into subtasks, and we are modelizing, and we are making a communication between one module with other module. Okay, and we are making the levels of abstraction. Levels of abstraction means first one user will be there. He will be having one level of access. Another user manager will be having one level of access. The supervisor will be having one level of access. Programmer will be having one level of access. Like that, for any project, uh, depending upon uh, depending upon the authorization and authentication, even in the application, not I'm not talking about only about the users. Even the applications also will be having abstract level of usage on other applications. So so this kind of computational thinking, as well as solving the problem, is nowadays came into the existence. Then coming to the data science, it's a cross disciplinary approach to solving the data rich problem. Okay, like machine learning, large scale computing, semantic metadata workflows, and all. Okay, so data science is data science, or a AM or ML works with the data science, right? So here in this, we will be talking about the machine learning and data analysis task. Then we will be talking about the classification. In the classification, we'll be talking about classification task, building a classifier, how we build a classifier, how we evaluate a classifier. Like that, we'll discuss. Then the third thing we'll discuss is pattern learning and clustering. So pattern detection, pattern learning, and pattern discovery, clustering, all these things we'll discuss. Then how we do the causal discovery, like correlation, okay, and causal models, simulation models, and we'll also discuss practical use of machine learning and data analysis. These things we'll be discussing in this uh, course, particularly on the machine learning, in this submodule of the total course. So normally, while analyzing, so here we are having normally different data analysis tasks, like classification, where what we do in the classification, we assign a category for a new instance. Second category is clustering. We'll cluster the total data into the individual data set. The third one is pattern recognition. Pattern detection is identify the regularities, like common patterns. Like if you are buying a bread, obviously you'll buy the tom. So that pattern. Okay. Then so classification is a top is it is about we are classifying any data or individual data to a particular class. Like when I normally in colleges they talk about the regular example, right? If in a applicant loan applicant is there, whether he belongs to the defaulter or a good customer, that is one class. That is two classes. So what we are doing, we are labeling a new instance to any of those classes. When a loan applicant comes, classes. So that we call as classification. So for that classification, what we have to do initially, we need to create a model based on the previous data. We have to create a class based on the previous data. So this model, what it will do, the model classification model will be creating classification model will be creating a prediction model using which whenever a new instance comes, that can be classified into anything. That we'll discuss in the further. So normally we have and mainly the data analysis or AI or ML tasks are based on the classification, clustering, and pattern detection and simulation. Okay, so classification where each type of task is characterized by kinds of the data and they require the kinds of the output they generate. So in this normally we'll take the data and we'll characterize uh, by the kinds of the data. Okay, so whenever a task is given, we'll find the data and get the data for the particular task and we'll characterize them, and based on the data only we'll create the classification or clustering and anything. So when we are doing this for creating a model, we need to learn. That means to create a model, we need to learn. As we discussed in the earlier class sessions also. So even our brain, how we take the decision whenever we want to take any decision, how we take the decision, it takes the decision by the previous learning. Say we want to, today we want to go a movie or not to go to the movie. So for that, the brain analyzes. How it analyzes? It tells us to view the reviews, or it tells based on the reviews, or reviews most of these days reviews are written not so some opposite people will write wrong reviews, positive people will write the correct reviews, so reviews are also not good. Then what we'll do, we'll consider the director, we'll consider the music or writer, we'll consider the music director, and based on, and we'll consider the hero, how he chooses the stories. I like that will our brain calculate and tells us two classes. One is to go to the movie or not to go to the movie, right? So how our brain is telling that it is previously learning the thing and it is creating a model. So learning is necessary to create a model where this model allows us to take the decision. So learning can be done by the data. So there are two different kinds of the learning. One is supervised learning, another one is unsupervised learning. In the supervised learning, the training data is annotated with the information to help the learning system. Like as I said, classification of a applicant, loan applicant, either a defaulter or a good applicant. How we have to decide whenever a new applicant comes. That how we will do based on the previous data. So previous data will be having previous applicants, all the applicants details, and how they closed their account as a good customer or they have become the defaulter. So that class label, with the class label, either defaulter or a good customer, and their data, all the data is given, and we learn from that data, that we call it supervised. Why? Because the class labels are already there. Then we are coming to the unsupervised data. In the unsupervised data, we will not be having any kind of classification. Just we will be given a data. From that, we will cluster them and we'll find the common pattern. And we'll based on that, we'll take the decision. Okay. So there are, for this classification data, array uh, supervised data, supervised analysis or unsupervised analysis, or a classification and clustering, we get the data from the different sets, different sources like GPS data, image data, okay, and different kind of the data. So when we are taking the data, we have to check, we have to check, or we have to, we need not to understand the actual in complex mathematics and a programmer to use this data. Okay, so normally whenever we are taking the data, we'll collect them into the categories or a specific column values. Then we start giving that to the learning model. Okay, so like first, say we are talking about the classification. So from where this classification comes. Okay, so before going to the classification in depth, what are the classification tasks and building a classifier and evaluating the classifier, we'll go and discuss little more stuff. So in the machine learning, we have to learn different uh, learning algorithms. So that is supervised learning or unsupervised learning. Okay, where this learning algorithm will create a model from what they will do. Say a face recognition model is there, email spam detection is there, market segmentation model is there. So these models were inferred from the data using the learning algorithm. So what the model will do, whenever a new instance comes, they will tell us what, how it can be performed. Like we created a, using the learning algorithm, we created a learning model. How we created, we will take two things. One is from learning algorithm and another is from the training data. We'll create a learning model. What this learning model will do, whenever a new object comes, which class it belongs to, which class it belongs to, it will be notified. Okay, so that is what any learning algorithms work. So there are different types of the machine learning model. One is classification, which predicts the category of input objects. That normally, as I said, whenever a new applicant comes, whether he's a defaulter or a good customer, that classification can be given using the classification. Like object recognition in images, that is also one part of the classification. Email spam detection, that is also part of the classification. So there are machine learning classification models will be there. At the same time, regression models will be there. Okay, regression models predict real valued output for a given input. Okay, so like predicting a value of a stock, predicting the number of clicks in an advertisement. So stock means how the stock will grow, stock value will grow or decrease. That comes under the regression. So this is regression learning model. When we create a regression learning model, using that, we can predict a value of the stock. Third category is clustering. Okay, this is grouping the objects into a homogeneous cluster, which clusters are not defined, like market segmentation, anomaly detection. All this comes under the clustering. So whenever you are talking about object recognition in image, then you have to, mostly the basic model is, machine learning model is classification. So you are talking about the predicting a value of the stock, or a predicting your next salary, or predicting the right, predicting anything like which is a continuous. That when then we go with the regression learning model, or a clustering when there are the data is not pre-classified, and by grouping them we need to uh, generate a analysis model. Then we go with the clustering machine learning model. So in this, market segmentation, that means separating the market into different groups. Like so we have the customers, rich customers, poor customers. or average customer or customers who are interested in mobile. Like that, based on the data given, previous classification is not there, but observing the data, we can group the customers into different categories, right? Like market segmentation, anomaly detection, and in industrial plants and all. So, so these models, classification models, regression models, clustering models are used in this type. There are different models like uh, when we talk about the learning algorithms, we talk in terms of the predictive data analysis. We talk in terms of the exploratory data analysis. Exploratory data analysis. Predictive data analysis is analysis where we predict for the future occurrence. Like this applicant, he may become a defaulter. This applicant, he may become a um, he may become a defaulter or he may become a good customer. So this prediction, we call it as predictive data analysis. Exploratory data analysis means exploring the data. Like the data is given, a group of employees information is given, a group of employees queries are given, and we are combining the queries and we are observing which queries, mostly which type of queries were asked. Like most of the queries when we will be onboarded or to the project. So that group is collected. Initially, that what we are doing, we are exploring the data. We are not initially we don't have any idea how the queries will be, but once all queries were collected and they are grouped based on their purpose, then we can explore the query, right? So ex- there are two kinds. One is predictive data analysis. Second one is exploratory data analysis. Predictive data analysis comes under the supervised learning. Unsupervised learning comes under the exploratory data analysis, where in unsupervised output is not specified and natural groups are to be determined. In the supervised, for each input in the data, training data, the desired output is known. Like as I said, either we classify them into the employees from 4 lakhs to category A, category B, category C, like salary ranges from 4 to 8, 9 to 12, 13 to 16. So this is, we are predefined. That we call as supervised or a predictive data analysis. When we are using when the output is not specified, then we call it as exploratory data analysis. The third category is semi-supervised. And this semi-supervisory output available for few data points and output not available for the most of the data points. Okay, that means it is a combination of the unsupervised as well as the supervised data analysis. Okay, coming to the classification and regression and clustering, we have to learn this basic algorithm. In the classification and regression, we'll get the logistic regression, Bayesian learning, KNN, K nearest number, decision tree, support vector machines, random forest, XGBoost, neural network, and deep learning. Coming to the clustering, clustering means unsupervised learning. Classification and regression, we can define them in terms of the supervised learning. Clustering is unsupervised learning. In the clustering, we have to know what is K means clustering, what is hierarchical clustering, what is DB scan clustering. Okay, those things. Linear regression is a regression. See here, linear regression means whenever you're observing a data, you can see the data is like this. This is X columns and this is Y. Any point is a XY point, right? So when all these red dots or the a graphical representation of xy coordinate. When you see, you can easily draw a line in between them. So they are like distributed like this. So this linear regression happens like, say you want to predict the stock price. Stock price is normally, it is not completely, it is, the data is a sequential mostly. Right? Sequential means either it go up or down, up or down, up or down, and we can draw a line between them, right? So in such scenarios, like increase prediction of the temperature or prediction of the salary, they are not completely randomized into the different places. They are in a sequential model where we can draw a line. In that scenario, we use the linear regression. Linear regression where we can draw the line and we know a equation for the line, right? As you know, uh, y is equal to some mx plus c or something, line equation will be there, right? So like that, if your salary here, if, when we draw a line and if this line is extended to like this, when you know the x value, when you know the x value, because of the line, you can know the y value also. Say we are talking about the years of experience. So the first year he is getting that 30,000 salary. In the second year he is getting the 40,000 salary. In third year he is getting the 35,000 salary. Then we can draw a line, right? Then we can predict at 10th year how much salary will he will get. If you know the x value in terms of the year, we can know the salary uh, in terms of the price, right? So this kind of data and analysis can be done using the linear regression. And logistic, say another category is logistic regression. In the logistic regression, we can predict if the student will pass an exam depending on how many hours he has studied. So that can be done based on the previous data, right? That also will discuss. So logistic regression is a kind of regression based on the hours studied and what is the probability of his passing in the exam. Okay, you can draw a line here using this computation. Then coming to the k nearest neighbors. K nearest neighbors is another method. Okay, for an input text of an input, k nearest neighbors of of input text, x are training data points that have the k smallest distance to the x. So for in the when we are calculating for for a particular x value, what are the nearest neighbors? Based on that, we will predict the output. So that is one method, k nearest neighbor classification. So find a how this classifier works. Find the k nearest neighbors of an input data, count the class membership of neighbors and find the majority class, and the majority class is predicted for the class input. Okay, that is k nearest neighbor. We'll explain all those things in depth in the continuation. And for this, we'll find the distance measures and all. Okay, for k nearest number, where we use bootstrapped aggregation also, bagging also. Okay, and the another category is decision tree. Decision trees is a classification method where we divide, we create a model in this scenario. Say here decision, I have given the task also. In the while we are creating a decision tree based on the previous classification data, that means the people whether they survived or not survived, or died, survived or died. These two classes we have. You can see the list. They're survived or died. Complete lists are only two classes, whether they have survived or died. This is based on their by classification. Okay. So of the Titanic. So what happened? If female, based on the previous data, if they're female, most of them are survived. Okay. And if they're male, okay, if their age is less than 99.5, okay, they died. If age is greater than 9.5, again another factor is there. Based on that, if it is less than or greater than, either they are died or survived. So leaves denote these classes. So this is the decision tree which will generate by using the decision tree classification, right? So what we do in the decision tree construction, that also I'll explain in the future sessions. Splitting the best decision attribute A for the next node. For each value, create a new descendant of the node. That with the example I'll explain. Otherwise, you will not understand. Why we need to learn in depth of these things? We have the decision tree, we have the KNN, we have the regular expression, linear regression, okay, and all KNN or XGBoost, all for all these Python scikit is having giving the different functions where we can directly use this function. But as an AML engineer, we should know when to use, where to use, how to use these algorithms. So this you can know only if you understand, the in-depth concept of each of these. Like when we use the decision tree, when we use the KNN, when we use the linear regression, okay, or clustering, okay, or a random forest, okay, or a boost. What is boost? Okay, what is additive modeling? What is gradient boosting? And what is gradient boosting for the regression? Okay, so what is XGBoost? What is clustering? Clustering of the data. And how we do the clustering? What is k-means clustering? What is k-means clustering iteration? Okay, all these things, if you know well, then only whenever a new application comes, you should be understanding which type of uh, classification or clustering you will be either you will use. First you go for the supervised learning or a unsupervised learning. But then you will in a supervised learning, whether to choose which type of algorithm, what are the latest algorithm, okay, and which algorithm should be used. Those things you should know. Then how you will know? Only when you understand each of these algorithms, like what happens exactly inside the k-means, what happens exactly inside the other clustering algorithms, what happens exactly in the classification. So when you know them, then only you can uh, understand whenever a new problem comes, which type of learning model has to be applied on that. Otherwise, you will not be understanding in a real time. Say, if I ask you to apply XGBoost or a decision tree modeling on a data, that you can simply do by given data by simply applying the decision tree, and you can give the output. That anyone can do, even the first year student also will go, or a BTech first year student also he can do, because all the specifications are given. But when it comes to you to take a decision, you should know all these things. What is decision tree, when it has to be applied? What is KNN, when it has to be applied? What is the regression, when it has to be applied? What is reinforcement learning, when it has to be applied? What is deep learning, when it has to be applied? And when you know for which kind of application, which type of algorithm is has to be applied, the other things will become easy. For that, all of you should know all these things. So, for but as we all of you already